This is section 5.04 of the Unit 5 Notes, Investments. Today I am, as in you are the student, applying the rule of 72 and compound interest to investment accounts so that I can calculate investment amounts and the amount needed to retire. I will know I have it when I can solve problems involving the rule of 72 and retirement contributions. Specific teaks we're looking at for today's lesson is 4C, analyze types of saving options involving simple and compound interest and compare relative advantages of these options. So we're going to look at different types of investments. We're going to look at 401k, stocks, bonds, and other problems that involve investing your money into something. What are investments? Could be anything like you invest your money into a painting that will eventually grow in value 5 years down the line. Could be anything like a piece of property. Could be a Pokemon card. It could be other different physical things, or it could be digital like Bitcoin or other cryptocurrency as well. Whatever it is, you put your money in with the intention to grow later on, to either just have it stored in value or to sell it later for a profit, for money. That is an investment. You're investing your money, you're putting your money into something in order for it to grow over time. So we're going to be looking at different things involving investments in this lesson. One of the things we'll look at is a rule of thumb called the rule of 72. What is a rule of thumb? Rule of thumb is just, it's a general rule. Doesn't always mean it'll be correct, but there's a general rule that like 4 times out of 5 will be correct, or maybe less. But either way, a majority of the time it is correct, that you can rely on it a little bit, not all the way though. This rule of thumb will allow you to make a quick calculation to see what's going on with it. Okay, in the case of the rule of 72, the rule of 72 is the approximate number of years it takes for an investment to double in value. Again, doesn't mean it will. It's just a rule of thumb for most of the time will actually occur. But you still want to be wary about actually trusting it. It'll just give you insight on what the rule is for. Okay, so in this case, again, how many years will an investment take to double, depending on the rate of return? So the formula for this rule of 72, the number of years it takes for this investment to double, is 72 divided by the percent rate of the return. Do not change the percent to a decimal. So this is one of the instances where we want to keep it as a percent in order to do the math. So for example, rule of 72, if your rate of return, meaning the amount of money you make, like say for example you invest $100 in and your rate of percent of return is 12%. That's $12 that you get back from your $100 investment. In order for your $100 to double, you take that percentage and then divide it into 72. So 72 divided by 12, $100 will double to $200 in 6 years based on your rate of return. If you invest $100 at 6% return rate, it'll double in 12 years based on the math. If you have a rate of return of 3%, then it'll take about 24 years for $100 to turn into $200. It'll take 24 years for it to do that. So that's what this rule is for, to kind of approximate, guesstimate, or estimate, whatever word you want to use. Approximate the number of years it takes for an investment to double. So let's look at an example. And, so let's look at example 1. If an investment is expected to grow by 9% per year, how long will it take for the value to double? So using the rule of 72, we take 72 divided by 9. If you want, you could take out your calculator for it. 72 divided by 9, and we get 8. So this means it's going to take 8 years for an investment to double. Okay, why is this relevant? Well, it'll give you an idea if trends continue, how long it'll take for your investment. Like, let's say you decide to put in $10,000 and you want it to double to $20,000. You can expect your $10,000 investment to double to $20,000 by about 8 years, if you have a 9% rate of return. So things like that to kind of get you to see into the future of when your investment will pay off, when your investment will pay off approximately. So, but anyway, so that's it for example 1. That's all there is to it. So you try number 1. Go through this problem, fill out the blanks, and move this box right here to see if you're doing everything correctly. So I'm going to read the problem, and after this problem, after I read, I would like y'all to pause the video and try this problem on your own. So here we go. If an investment is expected to grow by 15% per year, how long will it take for the value to double? So again, at this moment, I would like for y'all to pause the video and try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So 15% per year is the rate of return. It's expected to grow. The investment is expected to grow 15% per year. That is the rate of return. How long will it take for the value to double? Value to double should signify that you're using the rule of 72s to approximate how many years it'll take to double. So 72 divided by 15, again, keep it as a percent, and then whatever answer you get will be the amount of years it takes for that investment to double. So 72 divided by 15 is 4.8. So if we were to round this, let's say this would be about 5 years, 4.8 years, about 5 years for my investment to double. So for example, if I want 10,000 to turn into 20,000 with its current rate of return per year, if it stays static, if it stays the same, it'll take about 5 years to go from 10,000 to 20,000. Yeah, 4.8 years. And that is it for you try number 1. Okay, now we're going to look at a rate of return, and we're going to do a problem involving buying stocks and selling stocks, and then figuring out what our rate of return is from playing the stock market there. Okay, so we're going to go through an example where you have to go through a stockbroker. If you don't know what a stockbroker is, it's a financial expert who buys and sells stocks and other securities for clients. That may also be called registered representatives or investment advisors. Their responsibilities when you hire a stockbroker could include, but not limited to, researching financial reports and listening to earning calls, analyzing market trends, monitoring government actions that affect the market, the stock market, managing client portfolios, advising clients on buying or selling, and then staying updated on regulations, taxes, and financial news in general. Each stockbroker or company that is involved in the stock market with stockbrokers, etc., may, or whoever is employing them, the employer, their fees, their commissions may vary depending on what it is that you're having them do. So we're just going to go through one scenario that involves commissions through paying a commission through a stockbroker here. Okay. Anyways, let's get into rate of return here. Rate of return is the net increase in value divided by the original cost. So the original cost of the share. The net increase in value is the increase or decrease from the time you buy the stock to the time you sell the stock. Okay, we're going to see how much it increased or decreased at that time, and that's the rate of return. Okay, so this problem that we're going to go through, I'm going to go through the steps, which will make more sense when we actually go through the problem. But for right now, I'm just going to preview what we're going to do here. We're going to calculate the original cost, which the original cost of is buying the cost per share times the number of shares that were bought. We're going to calculate the selling value, which is the values of the share when sold, what the price is, times the number of shares sold. We're going to calculate the increase in the value, which is the selling value subtracted by the original cost. and then calculate the net increase in value. The increase in value minus the commissions when bought and the commission when sold. In this particular scenario, the stockbroker is asking for a commission for handling your money. That commission, his stipulation or her, is a certain amount for buying the stock and selling the stock. So that's the type of problem we're going to be looking at for in a little bit. And then calculating the rate of return. We're going to change our decimal to answer to a percent after we find the rate of return in its decimal form. So again, net increase in value divided by the original cost. The amount from step 4 divided by the amount from step 1. So let's look at example 2. I'm going to cover this up and reveal it as we go. So Angelica bought 800 shares of a company for $7.94 per share. She pays a broker a commission of $16 to buy and sell the stock. After 1 year, she sold all her shares, which were worth $8.75 per share at the time. What was her rate of return? So here's the information, what I circled and underlined. Where do we start with this? Well, first, let's figure out how much she bought. What was her price for buying 800 shares at $7.94? So step 1, calculate the original cost, which is the buying cost per share times the number of shares bought. So that means I'm going to multiply 800 with $7.94. And the original cost was $6,352. Okay, so that is the original cost. Next step, calculate the selling value. So we know that she sold all of her stock at $8.75. So how do we calculate it? Same thing as before, except we're going to use the number the price of the shares when we sold them, and then multiply by the number of shares sold. So the price in this case was $8.75 when sold. We're going to multiply by the number of shares we've sold, which is 800, and we have $7,000. So the cost or the price that it was sold for was $7,000. Okay, next step. Calculate the increase or decrease in value, because we could have sold this at a loss. Now, it's obvious, looking at the original and the selling value, it increased. So we know there's an increase in value. But there could also be a decrease in value as well. So we're going to take 7,000, subtract 6,352. And we get $648. So that is the net increase. Well, I'm sorry, this is just the increase in value that we have. So now, the next part, okay, this is how much we made from buying and selling that stock. Now, we need to calculate the net increase in value, because what we also haven't factored in yet was we paid a broker to do this, to help us through this financial transaction. So we have to pay the broker their fee for handling this. And their fee, each time for when we bought and sold, was $16. So that's why we're going to take this value right here, subtract 16 twice, because 16 when they bought and then 16 when they sold, which means the net increase is $616. Now, notice how step 4 and step 1 are circled. We're going to use these two numbers and divide them to find the percentage of the rate of return. So to calculate the rate of return, we're going to divide 616 with 6,352. We're going to change this into a percent by multiplying by 100. And we get, let's say, to the nearest decimal, 9.7% return. If if we were to round it, 9.7% return. And that's about it. That's it for example number 2. Just as a quick aside, if I want to know how long it'll take for my investment to double, if my return is 9.7%, let's say 72 divided by 9.7, it's going to take about 7 years for my investment to double in price. Okay, so this is just an aside. This is not a part of the problem, but just to kind of circle back on the rule of 72, it's going to take about 7.5 years for my investment to double in price. Okay, and that's it. So, well, this is the answer for example number 2. But anyways, let's move on. Now we're going to do you try number 2. So at this moment, I would like for y'all to do the steps to these problems, to this problem, and see if you can figure out how to calculate the rate of return. And then at the bottom, if you're doing everything through ClassKick, just move this box and check your work to see if you're doing everything correctly. Let me read through the problem, and then y'all can go ahead and try this on your own. Andrew bought 500 shares of the company's stock for $5.95 per share. He pays a broker a commission of $50 to buy and sell the stock. After 1 year, he sold all his shares, which are worth $8.75 per share at the time. What was his rate of return? So at this moment, I would like for y'all to pause the video and try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So Andrew bought 500 shares for $5.95 per share. Step 1, to calculate the original cost, we're going to look at those two numbers there. The buying cost per share, which was $5.95, times 500. Or 500 times 5.95, doesn't matter. Either way, we get $2,975 for the original cost of these shares. Okay. Now, next thing we want to do, we want to calculate how much it was when he sold all of these shares. So, this is still 500 shares. However, the price is now different. After 1 year, he sold all of his shares, which are worth $8.75 per share. So now we're going to multiply 500 with 8.75. Which turns out to be $43.75. Okay. Now we want to calculate what the increase of that value was from bought to sold. So we're going to multiply the subtract from the selling value the cost. So $43.75 minus $29.75. Which I believe should be about $1,400. Let's see. So $43.75 minus $29.75. Yep, $1,400. So $1,400 is the increase in value. Now, we need to calculate the net increase because what we have not factored in was the broker's commission. So the broker gets a commission of $50 to handle Andrew's money. Okay, so Andrew has to pay a commission of both when they bought and when this broker bought and sold the money, helping Andrew through this process here. So $50 is for each buy and sell. So we're going to take $1,400 and then subtract 50 for when he bought and then 50 for when he sold, which is subtracting 100, which will be about 1,300. And I'll just show you on the calculator just to make sure you all understand. So minus 50, minus 50, and we have 1,300. Okay. Now, to calculate the rate of return, we're going to take answer 4 and then answer 1, the net increase and the original cost, and we're going to divide them. So 1,300 divided by 2975. We're going to round our decimal answer to 3 places just for the sake of this class kick. So 1,300 divided by 2975 to 3 decimal places is about 0.437. 437. Now change the decimal to its percent by multiplying by 100. So multiply this by 100. And we have 43.7%. Which is very good, mind y'all. 43.7% return rate. And that's it. That's it for you try number 2. Just to make sure we did everything correctly. Yep, 43.7%. So he bought at $29.75. He sold at $43.75. His net increase with that commission is about $1,300 after we subtract the 2, and then subtract the 2 commission values. Divided with the original cost, we get our decimal answer, then multiply by 100, we get 43.7% as his return rate for this stock investment. And again, that is it for you try number 2. Now we're going to shift into calculating interest earned, and we're going to talk about bonds in our next example problem in a little bit. So first off, calculating the interest earned, we have a simple interest formula, I equals PRT. You may have heard of it as the PERT formula. I is the amount of interest earned, P is the principal amount, R is the annual interest rate, and then T is the time in the number of years. We're going to modify this a little bit because the interest can be paid out depending on a certain amount of things. There's different ways to compound the interest, either daily, which is 365 times of the year, semi-monthly, which is 24 times a year, monthly, which is 12, quarterly, which is 4, semi-annually, which is 2. So if you ever want to receive interest, usually daily or infinitely compounded is the way you want to go. The less it's compounded, the less money you will make in terms of interest, or the less money that you would owe if you're having to pay that interest to somebody. So step 1 with the problems that we're going to do is to identify the values for the P, R, and the compounding periods, because we're going to be doing this. This is going to be a fraction, the time it takes. The amount of time it takes is going to be a fraction. We're going to plug into the formula and then simplify. Okay. So before we do that, let's talk about bonds real quick. What is a bond? A bond is a loan to a company or government that pays interest to the investor. Bonds are a type of investment that can help diversify a portfolio and provide a steady income. How do bonds work? So the issuer, the person giving out the loan, the company or government needs money, so they sell bond to an investor. That investor lends money to the issuer for a set period of time. So let's say this issuer sells this bond to somebody. The investor gives that money to the issuer for them to use for whatever it is that they may need. So the investor lends the money to the issuer for a set period of time. The issuer, the person that takes out that bond, will then have to pay interest to the person that invested that money for them. Okay? The issuer pays interest to the investor at regular intervals. And then when the bond matures, so let's say they take out a bond for 5 years, at the end of the 5 years, let's say they loaned out $1,000, they have to pay that $1,000 back at the end. Okay? So those bonds, they're meant for money now, and they pay the interest to the person that they got the loan from throughout the years, throughout the amount of times that they have to pay their interest. And then at the end of the the bond, it matures, and then they have to pay what they borrowed back. Okay, so that's what a bond is. That's how it works. And hopefully that makes sense. If not, y'all could probably Google it or search up a YouTube video about it. But that's I hope it makes sense. That's all I'll say. So let's look at an example. An example that involves simple interest. Amy bought a bond with a face value of $20,000 and a coupon rate of 9.5%. What is a coupon rate? Coupon rate is basically what the interest rate is going to be no matter what. That's the amount of interest that that person is going to be receiving, whoever it is that loaned out that money to them. The coupon rate is going to be 9.5% each time they pay their interest. So the bond will mature in 20 years. How much interest will she receive semi-annually? So let me cover this up and then reveal it as we go. So the interest formula, I equals PRT. P is the, where'd it go? P is the amount that you're buying the bond for. R is the rate, the coupon rate. And then the T is going to be through a fraction, the amount of times you're compounding the interest. So to fill out the formula, we know P, the principal amount, is $20,000. We know the rate is 9.5%, which as a decimal is 0.095. And how do I figure that out? Well, you can either move the decimal point to the left twice, or you can take 9.5% and divide it by 100. And we get 0.095. And that's the rate that we're going to use. Now, how much interest will she receive semi-annually? Well, semi-annually means 2 times a year. Okay? So now, filling in the formula, we don't actually need the 20 years. Because we just want to know per compounding period how much interest she will earn each time, semi-annually. So now we have everything filled out. P, again, 20,000. R, 0.095. And then 1 divided by the amount of times she's compounding this bond, which is 2. So 1 divided by 2. Plug all of this into the calculator because, as you can see, the right side, there's no missing value. There's no equation we have to solve. So we can just simply plug everything into the calculator. 20,000 times 0.095 times 1 over 2. 1 divided by 2. Okay. I don't need a parentheses there. We get $950. So this is the amount of interest that she will earn semi-annually. $950. And that's it for example 3. So again, Amy bought a bond. So she invests $20,000 into something at a rate of 9.5%. She will get back, whoever it is that she lent the money to, 9.5% semi-annually. So after 6 months, she'll receive money. After another 6 months, she'll receive money again. And every 6 months, she will receive the same amount of money each time. So how much interest will she receive semi-annually? Well, to calculate that, again, 20,000 times 0.095 times 1 over 2 for semi-annually, which is $950. So whoever she lent the money is paying it back, is paying the interest at $950 each time. And then when the bond matures after 20 years, that person will have to pay Amy back the $20,000 that she invested in them. Again, this is how bonds work. Hopefully that makes sense. But anyways, that's it for example 3. So let's look at you try number 3. Again, go through the problem. Try to enter the information as best as you can. and then move this box to check your work and see if you are doing these things correctly. I'm going to read the problem, and after I read the problem, go ahead and pause the video, try this problem on your own. Here we go. Alex bought a bond with a face value of $15,000 and a coupon rate of 8.5%. The bond will mature in 15 years. How much interest will she receive quarterly? So at this moment, I would like for y'all to pause the video, fill out each of these boxes on your own, and see if you can solve the problem by yourself. Otherwise, I'm going to continue on and show y'all how to do this. So again, Alex bought a bond with a face value of $15,000. So he is investing $15,000 to somebody, a company, whichever. The coupon rate, which is how much she's going to get back quarterly, is 8.5%. The bond will mature in 15 years. We don't really need that at the moment. But so to figure out how much she will receive, we need to figure out what information we have. So we know we don't know. That's the amount of interest we're trying to figure out here. Okay, so I is not available. For the principal amount, how much she's investing, that's $15,000. The rate is 8.5%, but as a decimal, move the decimal point to the left twice or divide it by 100, and we will get 0.085. The amount of times that this interest is being compounded is quarterly. Quarterly means 4 times a year. So 4. Okay, now let's put everything that we have into our simple interest formula. We have I equals 15,000 times 0.085 times 1 over 4. Notice how the I is by itself, so we're just going to take the entire right side, plug it into the calculator, and then solve. So we have 15,000 times 0.085 times 1 over divided by 4. And we have $318.75. So the amount of interest that she's going to receive quarterly, 4 times per year, is $318.75 each time. And that's it. So again, the bond, $15,000. Coupon rate, how much she's going to get back after investing $15,000, is 8.5% each time. The bond will mature in 15 years. Don't really need that information. How much interest she'll receive quarterly? Well, quarterly is 4 times. So she's going to be doing this 4 times a year. So 1 divided by 4 is the amount of compounding periods. And then to calculate the interest for each quarter, we just multiply all of that together and get $318.75. So from her investment quarterly, she will get $318.75. And again, that's it for you try number 3. Now, let's say as an aside, you want to figure out how much interest Alex will actually have for all 15 years. Well, let's take 318. So this is for every quarter. So this is going to happen 4 times per year. So this is 318 times 4. 1,275. That's for 1 year. 1 year. Now, this is going to take 15 years. So it'll take 15 years, so multiply by 15. And she will get $19,125 in interest on top of $15,000 that she did with her initial investment. So actually, besides this amount, if we add the $15,000, she will get a total of $34,125 back from her investment after 15 years. This is as an aside. It's not a part of the you try number 3, but just wanted to show y'all. Anyways, let's move on to the next problem. Okay, now we're going to go into a different problem again. So now instead of bonds, we're going to look into a little bit about 401ks and how to calculate the amount that's going to get deposited into that 401k account. If you don't know what a 401k account is, 401k is a retirement plan that lets employees contribute a portion of their paycheck to a savings account. How does it work? Employees choose how much to contribute, usually as a percentage of their income. It's automatically withhold. Employers automatically withhold the employee's contribution from their paycheck. The money in the account grows, tax deferred, meaning no taxes get taken out till it's withdrawn. And at retirement, distributions from the account are taxable except for a qualified Roth account distribution. So y'all can Google what that means later. What are the benefits of a 401k? Tax benefits. Contributions to a 401k are usually not taxed until withdrawn. Compound interest. The earlier you start contributing, the more time your money has to grow. So usually you want to start some sort of savings plan, some sort of retirement account as soon as possible and start investing it so that when you retire at around 60 something, 70 years old, or maybe you never retire, but you have an account that you can use while you're still working a different job, whatever. The earlier you start contributing to your 401k or your retirement plan, the more time it'll have to grow, and the more money you will be able to use when you retire. So that's one of the things about the 401k or any retirement plan in general. You want to start investing early to have that money grow over time. Additional information, 401ks are one of the most popular types of retirement savings plans, and employees can have other retirement plans in addition to 401k, and so on and so forth. So that's just a quick overview about 401ks. Now, another thing about 401ks is that some employers can contribute a certain percentage that you put into your account. So, for example, let's say employers will invest 5% of their money into your account, depending on the percentage that you invest into your account. And that's essentially, it's not free money, but it's free to you. They invest into your account depending on how much you invest. They sometimes match your investment into your account. So something to also consider about when taking out a 401k, especially through your employer as well. Okay, so again, we're going to calculate the amount that's going to be deposited into that account based on certain things. So we're going to go through the steps of this particular type of 401k problem, and then we'll go through an actual example. So first, a preview of the steps. We're going to calculate the monthly income, and that monthly income is the gross annual income divided by the amount of pay per year, whether you get paid weekly, bi-weekly, semi-monthly, monthly, whatever. And then step 2, calculate the amount that gets deposited into the account, which will be the monthly income multiplied by the employee deduction and the employer match percentage added together. And then remember, we're going to change these percentages into decimals. So let's look at an example. So Juan's gross annual income is $43,908. He is paid monthly and has 6% deducted from his paychecks for his 401k. His employer matches his deduction up to 4%. How much is deposited into Juan's 401k each payday? So, first thing we need to do is figure out what his monthly income is, because we want to figure out, he gets paid monthly, so we want to figure out how much he has to get deducted per month for this 401k. So, first thing we got to do is calculate the monthly income by taking the gross and dividing it by the pay periods, in this case monthly. So we're going to divide, let me take out the calculator. We're going to divide 43,908 by 12, the amount of pay periods he has, which is $3,659. That's his gross monthly income, $36.59. Okay. Now, step 2, calculate the deposit into the account. We're going to take the monthly income, the gross monthly income, and we're going to multiply with the sum of the employee deduction percentage and then the employer match percentage. So we're going to add those two together. So 3659 parentheses 6%, which as a decimal is 0.06, plus 4%, which as a decimal is 0.04, which will total up to be 0.1, but anyways, this will be $365.90. That will get deducted from his paycheck, or that will get deposited into his account, actually. That will get deposited into his Juan's account. $365.90. So only 6% will get deducted from his paycheck. And we could do that calculation if we want. But what's getting deposited into his account is $365.90 monthly. And so, yeah, this is not deducted. Will be deposited. Monthly. And that's it. That's it for example number 4. If we wanted to know how much he will get deposited monthly, we just take 3659 and then multiply that with 0.6. So there. No, I'm sorry, not 0.6, 0.06. So $219.54 will get deposited by Juan, whereas the remaining of the $365 will be paid by his employer. So that's essentially, quote unquote, free money because he's taken out a 401k through his employer. Anyways, that's it for you try number 4. I'm sorry, example number 4, you try number 4. Go ahead and try this problem on your own if you're following along in ClassKick. And then look behind this box to check your work and see if you're doing everything correctly. So I'm going to read the problem. And then after I read the problem, go ahead and pause the video. Try this on your own. So here we go. Jason's gross annual income is $25,708. He is paid bi-weekly and has 4% deducted from his paychecks for his 401k. His employer matches his deduction up to 3%. How much is deposited into Jason's 401k each payday? So go ahead and pause this video. Try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, so gross annual income is $25,708. He's paid bi-weekly and has 4% deducted from his paychecks for 401k. His employer matches his deduction up to 3%. We want to know how much will be deposited into the account each payday. So first off, let's figure out what his bi-weekly income will be. So we're going to take the gross annual income, which is $25,708, divided by the amount of pay periods that are in bi-weekly, which is 26 times a year. So divided by 26, 25,708 divided by 26, and we have $988.77. So 988.77. This is how much he gets paid bi-weekly. So now, to figure out how much he will be deposited into his account, we're going to take that value, 988.77, and then we're going to multiply with the decimals of the employee deduction and the employer match percent deduction. Well, the employer match, not a deduction. So this is 0.04 for the employee, Jason, how much he pays from his paycheck. And then the employer matches 3%, which is 0.03, which altogether will be 0.07. So from the calculator, 988.77 times 0.04 plus 0.07, which will be $108.76. So 108.76 will be deposited into the account each time. Again, will be deposited into the account each time. Oh, I did this wrong. I just realized what my mistake was. So I'm going to go back right over here. I did 0.07. That should have been 0.03. And then there we go. So 69.21 is the actual answer. So each paycheck, $69.21 will get deposited into the account, with 4% of it being his, Jason's, and then 3% being his employer. That's matching up to 3%. And again, that's it for you try number 4. Okay, and then the final problem, we're going to go through a rule of thumb. People don't know how long they will live or how much money they will need when they retire. However, a general rule of thumb is to save 10 times your gross annual pay to maintain your current way of life. So the amount that should be saved equals the gross pay times the pay period times 10. And again, this is a rule of thumb. This is not a law, a law set in stone, or anything permanent. This is just a general rule of thumb to approximate what you may need to retire. In this case, how much you may need to save to retire. So again, the amount that you should save is the gross pay times the pay period times 10. So let's look at an example. Karen's gross biweekly pay is $1,337. To maintain her current lifestyle, how much should she save up? So how much should she save up by the time she retires? So what do? First, we need to figure out her annual pay. $1,337 is paid bi-weekly. So what is paid bi-weekly? That means 26 times out of the year she's going to get paid. So her annual income is going to be $1,337 times 26. It'll be $34,762. Multiply that by 10, whatever that is, and we get $347,620. That's how much she should save up by the time she retires. And you can do this all in one go too if you want. And you'll still get the same result. I was just showing y'all step by step what to do there. So again, this is a rule of thumb to determine, to maintain her current lifestyle, what she's been living with for a very long time. To maintain her current lifestyle, this is how much she needs to save by the time she retires. When that retiring age is, no clue, but when she does retire, to maintain it for a certain amount of time, this is how much she needs to make it. I want to say retirement age is generally thought of at around the 60s. So I'm not sure about this rule of thumb, to be honest, if this is sustainable, because our life expectancy is growing as we evolve as a species. So again, take this rule of thumb with a grain of salt here. But now that you've gone through example 5, go ahead and try this on your own. Go through the problem, see if you can figure it out. Again, if you're on ClassKick, move this box to see if you can figure out if you can follow along and see if your work is going correctly. I'm going to read the problem, and then after I read the problem, go ahead and pause the video and try this on your own. Kim's gross weekly pay is $1,525. To maintain her current lifestyle, how much should she save up by the time she retires? So, gross pay times the pay period times 10. Go ahead and pause this video. Try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So again, her gross weekly pay is $1,525. So we're going to take $1,525 multiplied by weekly, which is 52 times a year. And then we're going to multiply that by 10. So 1,525 times 52 times 10. And she needs to save $793,000 to maintain her current lifestyle. Again, this is a rule of thumb. This is not for sure. This is just about how much she should expect to save in order to maintain her current lifestyle when she retires. Let me look up. What is general retirement age? So yeah, the general retirement age, which is about 62 to 70 years. It's saying 67 years, but in general, 62 to 70 years. Oh, I see. That's about when the Social Security benefits come in. So that's about that age that people tend to retire. There have been longer life expectancies, though, but that's the general age it's accepted for people to retire. But anyways, $793,000 is what Kim is expected to save in order to maintain her current lifestyle. And that's it. That's it for you try number 5, and that's it for section 5.04 in general. So if y'all have any questions, let me know, or if you have a different teacher, let them know. Feel free to rewatch this as many times as you want to understand the steps and the understand the contents of the problem and why you're doing certain things, etc. And again, if y'all have any questions, just let me know. Let us let whoever your teacher is know. Y'all have my information, your teacher's information in the course itself. Okay, so that's it. That's all I got for this video. I'll see y'all later.